Yeah, I'm back. It's day something, We're just surviving here, you know what I mean? I made my face a little bit bigger because I want to look at more of it, you know? So we're all surviving. Yeah, let's make that a little bit smaller. I don't want to look at myself that much. Okay, so I told you to start the day looking at worldometers. And I told you just to look around, have a good time, but I told you to end at this graph. Okay? And then I asked you the question, or if I didn't, I'm asking you the question now. Are humans currently in a state of overpopulation? That's a, oh, hold on. See that? Get that down there. Get away from me. There we go. Are humans currently in an overpopulation status? I guess you could say. Now, if we look at here, it looks like humanity is topping off right here at about 10.5 billion by the year 2060. But that's a projection. Look at where we're at right now. We're at about 8 billion. And right now, we see an exponential growth upward. So, as much as you'd like to hear it, we are not overpopulated yet. We are still able to provide nourishment to enough people on Earth so that the population continues to grow straight up. It is not curving yet, despite what the projections show. So we don't know that yet. What are some reasons why the human population would plateau? In other words, level off. What are some reasons? Go ahead and think about that. I'll give you a second. What's like the number one thing? What's the number one thing? Food, right? Food. I heard somewhere that if you took every single person in the world, you could fit them into Los Angeles, and every one of them could fit in a small studio apartment. So humans are not taking up as much space as people think. Okay, so there's plenty of space on Earth for us to live. I think it just comes down to the idea that possibly a lot of them are struggling, so at least in terms of like providing for food and water and shelter, right? So, or having that provision for them. Because if you live in America, you're already one of the richest people in the world. So that doesn't mean everybody's life is easy, obviously. Let's just move on, though. You know what I'm saying. What are some reasons that the human population would plateau? Let's have a chat about that sometime. But we looked at this last time. We looked at this last class, right? We looked at the interaction between a predator and prey population. And for all intents and purposes, let's think of people's prey just being food in general, just nourishment in general. If we were to look at can you see this? I'm going to put this over here. I'm pretty sure you can see that. If we were to look at any population of two organisms interacting with each other, and you just think logically here, if a predator-prey relationship looked like this, and the prey population were to start increasing like this, like crazy, all the way up to here, I'm going to draw a dot right there. If it gets up to this point, what's going to happen to the predator population? If you have a population that has loads of food, look at all this food for the predator, right? What is the predator going to be able to do? It's going to be able to, number one, survive. Number two, it's going to be able to reproduce, make more babies because it's staying alive longer, right? And if you stay alive beyond your infancy into reproductive age, you are making more of your species, right? That makes sense. And this is what happens. Look right here. As the food increases, so does the population of the predator species. But when this number gets too high, what do you notice? There's too many predators. When there's too many predators, the prey can't reproduce fast enough to provide food for the predator. So you start to see a sharp decline in the prey population. And you see that in this chart right here. Okay. And I know this looks ideal. This looks like, oh, Warner, you're just making a perfect chart. Well, bear with me here because I'm going to show you something real in a little bit. So prey population takes a steep decline. And if you cut the amount of food, what's going to happen? The predator population is going to drop. But when the predator population drops, what happens to the prey? Well, they have a less chance of dying, right? They have a less chance of getting hunted down, killed, and specifically before reproductive age. So you have an increase in prey population as this predator population is going down. As this starts to increase again, though, what happens, right? Predator population increases again. Okay, this is like a food cycle. Okay, it's an energy cycle. It shows how energy flows throughout a long amount of time, right? So this is extremely ideal, right? But I mean, stuff could come in that could happen, right? So there could be a population, there could be an invasive species that comes in. And let's do that. Let's do that right now. Or actually, we're going to come to that in a minute. It's a little bit lower. But I want to cover just a definition with you really quick, if that's cool. It's called the carrying capacity. You'll notice that this prey never just shoots off into oblivion. You know, it just never shoots upward. Or I guess into the heavens would make more sense. Oblivion's like down there. Woo. It never just shoots up. It's limited. It's limited. There's like an average, right? Or there's like a peak population right here. Same with the predators, right? It just kind of stops right there. That's what we call a carrying capacity. A carrying capacity is the highest population an ecosystem can contain given the resources that it has. Okay, so for example, I wonder if I can spin you around. Can I spin this thing around? Hold on. I'm going to just spin you around here real quick. Take a look at this classroom. Empty. You could be here. Okay, so I have like 32 chairs in here, right? So the carrying capacity for this room is about 32, right? I could fit 32 people in here and a teacher up front. I've got like 32 books, or maybe like 40 books. I've got like 40 pairs of goggles. I've got enough area for you guys to sit, and that is the maximum amount I can fit in here, given the resources I have. How many people could I fit in here, though? Like if I just, I don't know if you can see this right now, but like if I just lay down here, how many people do you think I can cram in this room? If I just stacked them up, all laying down, sardine style, all the way up to the ceiling, how many people do you think I could fit? That's what we call maximum capacity. Okay, maximum capacity is just how many you can shove in a certain area. That is much different from carrying capacity, which is what we're focusing on ecologically. So let's move that back just a little bit. Back it up. Okay. The carrying capacity is how many things can fit into an area given the amount of resources it has. Okay, so the carrying capacity of this population right here is whatever this number would be. Okay, it doesn't go above. Actually, it might even be a little bit lower because at some point it starts to plateau and then it comes back down. So it's like that healthy it's like that healthy average right there almost. But it's typically when a population kind of flattens out. Okay, let's take another look. Let's see here. Let's just look at a textbook example of carrying capacity. Oh, I'm lagging. I'm sorry if I'm lagging. Blow us away someday, someday. Yeah, you'll blow us all away. Ah, this is a good one. Name that musical that I was just singing while bored. Warner, move your good-looking face. Okay, so you see this, the population in millions of whatever this species is right here, and it's going up, 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 and then it overshoots, and it comes back down. Overshoots, comes back down. It's kind of like a stock market thing. Like if you've ever seen the stock market, how the numbers just kind of go up, or the lines go up and down and up and down. As it grows, that number, there's plenty of resources in this ecosystem, right? Until they overdo it. They overpopulate. And then there's no resources to feed all of them. They can't continue to go up and reproduce and make more babies of whatever this population is. It goes back down. But then when there's a lower number, there's more resources for the lower number, and then it goes up, right? Then it goes down. Why does it go down? Over here. It goes down because there was something that limited the population. And those are called limiting factors. Limiting factors are, let's go here. I'm going to add that. I'm going to add that to the side. Boom. Let's add that for fun. We don't typically talk about limiting factors, but I think it's important. Limiting factors are things in an ecosystem that limit the population of a species. Now let's throw it back to last time. Those limiting factors can be biotic, but they can also be abiotic. Oh, what happened? There we go. Those factors can also be abiotic. Oh. Okay. A little carried away there. Slow down, Warner. Those can be biotic or abiotic. So for example, okay, so I live on a street with 12 houses. The biotic or the abiotic factor that prevents other people from just slamming 2x4s next door to me is the road that I have in the middle of my street. That is a limiting factor for the number of people that can live in my small little neighborhood. Okay? And you can't build any other houses there because there's houses everywhere around it. You can't fit it. So that would be considered an abiotic limiting factor in my neighborhood. That would be the little ecosystem. Okay, so let's think practically here. Remember, last time we looked at this picture, remember, of Central Park? And I brought up the birds. Remember when I brought up the birds? Why can't I continue to go up here? Where's my... Dude. There we go. Okay. There are, let's say, in order for a bird to survive in this picture, it needed to perch on a tree in order to lay eggs so that scary foxes won't eat the eggs and the bird population can thrive. This tree right here and this tree right here and here, those are biotic limiting factors. If we added more trees to this picture, then you would presumably increase the carrying capacity for birds in this picture, okay? If you started taking away trees, you would lower the carrying capacity of birds because you're taking away the biotic factor of trees in this specific picture, okay? It's just an example. Look at all the abiotic things that have limited the amount of life in this picture alone. You've got the concrete. That took away so much area for small life to live in that area because it was replaced with an abiotic cement right there. All of this area took space from another organism that could have lived there. Now, I'm fine with that. Like, I mean, we gotta take care of ourselves first, you know. This park is important for humans, so I'm not like, oh, save the bugs. Oh, I am shedding tears over bugs. Like, you know, that I'm not like that. But it's just a reality, you know. Other species are affected when other species come in and kind of take over. And it's not just a human thing. Don't emotionalize this. It's not like humans are evil and we ruin the ecosystem and other organisms don't. We just got done talking about stink bugs and how they are an invasive species and they ruin stuff too. So yeah, I mean, do we negatively impact the environment? Yes, sure, I agree. But I mean, have we also like increased the average lifespan of all of mankind? Yes. So like we're not completely evil things that just take over the world and put parks down for kids to have fun. Ugh, I hate happy children. Whoa, slow down, Warner. Getting all riled up. His parents are gonna hear and start getting mad at me. All right. Hey, anyway, we got to stop right here because we've got our first stop. What did I have for you? What did I have for you to do? Right here. It's actually in between here. Go to tinyurl.com/Warner Isle Royale and watch this video. And then we'll meet back live and I will tell you what to do. You have a document coming up that you can find in your modules in Canvas, just like always. So, or get used to it being always. Okay? So I will catch you later, or I'll catch you another time. See ya.